So, hello everyone. My name is Brooks Patrick. I work here on the 3D team at Esri in the Redlands office. Today's topic is all about the application of 3D GIS for comprehensive planning. Eric Brady is actually going to dive a little bit deeper into the tools that have led his firm to implement some of the largest 3D models and regional 3D models that we've seen, supporting anything from zoning to development review to regional planning, just to name a few. So over to you, Eric.
So Bergman Associates, we're an architecture, engineering, and planning firm, and we have a long tradition using 3D technologies in our practice. So the architects are rendering out beautiful buildings with 3D, our engineers design bridges, highways, and dams with 3D, and our planning work uses 3D visualization as well. And so these visualizations for planning have proven to be very effective. So you can see here one of our visualizations where it really helps portray that community's vision for growth. But as beautiful as it is, there are some limitations. In this model, there's no data behind the buildings, and it's compiled as a simulation, so it really just captures one moment in time, one version of the plan. And it's also developed with sophisticated graphic art tools, so it's not easily modified using traditional planning tools. And planning offices generally don't have those capabilities. So we started to ask ourselves, well, what about GIS? GIS data was always an input to these graphics with the elevation models, parcels, building footprints, tree points, and zoning as inputs. And we knew that our customers had GIS skill sets as well to help manage these scenes. And we started looking at why don't we just use GIS exclusively? So years ago we started with ArcGlobe, and what you're seeing here is one of our earliest models of a university campus, and it proved very effective as a visualization tool. Then CityEngine was released, and that really became a powerful tool to integrate lots of data and to publish easy-to-use web scenes. And now ArcGIS Pro is proving to be a very powerful desktop 3D tool. So one of our earliest examples of 3D GIS was with the City of Rochester. And here we are looking at a CityEngine web scene, and this is a rich model that was used to support the city's master plan update. The web-based GIS allows the city to share the plan with stakeholders, giving the public an understanding of how the existing built environment could be affected by the plan update. CityEngine's parametric modeling tools allowed us to develop representative models to convey the form-based zoning code. And the models were intended to show the types of infill development that were supported by the zoning code, both in size and density, but also architectural features like window coverage, setback, and facade material, to help people understand what kind of buildings would be in their neighborhood potentially. Another powerful use case for the base map from this project was the idea of site plan review. So here we're looking at a new bus station that was constructed in the city, and by taking the architect's BIM model, the city was able to integrate the model into the base map for stakeholder review. And this allowed the public and decision makers to really understand the visual impacts of this proposed construction. So these CityEngine web scenes really prove the viability of a 3D GIS base map for visualization, but as GISers, we really were interested in the data as well. So for our next project, we really wanted to create an intelligent 3D base map to support planning analysis. And here Esri was really helpful in providing a framework for a 3D planning information model. And this is really a flexible geodatabase design that allows users to join any number of data to their building models. So of course we have our multi-patch models, whether they be simple massings or very detailed textured models. We have traditional planning vector data like zoning and land use parcel information, but we can also join standalone tables with relational data that might support our building and analysis. All of this information is joined to the building footprint in the map and then associated to the model. So we were able to prove this out with a project we conducted with the City of Charlotte, North Carolina. And here we're looking at a web scene published from ArcGIS Pro, and these cyber city models have been joined and visualized, symbolized by one of the many attributes associated with them. And here we're showing square footage. And this is, because we have attributes, we can do things like link a hyperlink out to the county's real property website. We can bring in our vector planning data as well to help understand and do some really interesting visualization and analysis. But because this information model is flexible, richly detailed and textured models could also be added into the geodatabase, and here we see them streaming in. So they can support use cases where accurate-looking models are also needed. So for us, the Charlotte project really showed the value and viability of leveraging traditional GIS data within the base map and joining it to the base map for use in planning analysis. And now our current project is with the Cape Cod Commission in Massachusetts, and what we're doing here is looking how we can use ArcGIS Pro, intelligent data, and 3D planning tools to support common planning functions. This is a really great project. It's got an aggressive schedule that we're right in the middle of, and I can't say enough of what a great partner the Commission GIS folks have been in helping with this project and moving it towards success. But the project goals are pretty straightforward. The goal is to develop a 3D GIS framework to further regional initiatives as a strategy to educate the county constituents concerning land use choices, density, building form, and wastewater treatment efficiency. So what we're doing in the project is we're first creating a 3D base map of the entire Cape. It's over 260,000 structures. The majority of these models will be created with City Engine's parametric rules, but there are specific project areas that have been modeled out by a vendor, PLW ModelWorks, one of our partners. And these models are then joined with rich attribution, and some of this is used to assign baseline impacts for every structure, understanding the parking, water use, population, and job impacts. We're creating zoning envelopes similar to what you saw in Brooks' example, and then we're implementing a new tool we're finalizing called Impact 3D. So to give you a little sense of the scale of the project, we're going to fly over part of the Cape here. We're using ArcPro's animation tool, made it very easy. And we can see below us as we slowly stream over the area here in the Cape, our parametric models. We call these monopoly houses. And these models really are not meant to be hyper-realistic. They're created with the City Engine rule package that extracts the building footprint to a height. And now here we see the PLW models with a little bit more accurate architectural features. And this is Hyannis in the Cape. And now we'll zoom into one of our parametric models again, and here we can see the rich attributes that have been assigned to them as we identify in ArcPro. So there's impact, build-out impact variables here we see, and these are assigned to every structure. And then we have all of these additional attributes that have been joined through those spatial and attributional relationships. So Impact 3D is a ArcPro add-in that we've developed and we're just finalizing, and it really supports interactive 3D scenario building to visualize and understand the build-out impacts of potential development in the community. This tool will be on the Esri Marketplace. We're really excited about this in June, and we do have a beta program, and if you're interested, we'd love to work with you and see if we can't get you stood up with a test license. So let's talk about what the tool can do and how the Cape Cod Commission will use it. So in this example movie here, we have an infill parcel that we want to understand what the impacts might be. So what we're first going to do is we're going to visualize the zoning constraints. Then we're going to open up our massing tool from Impact 3D. The first step in developing scenario building is to trace a building footprint. And here we want to make sure we're inside the setback limits. Our next step is to define the size and type of building here. So we're going to dictate the number of stories, the floor height, and some texturing attributes. We have a whole library of different facade types, but here we're just using a suggestive facade to represent window coverage and really just give a representative view of what a building might look like on this site. And this again is sort of that fundamental visualization capability that we've talked about and we've seen so much. But really we want to understand the impacts of this building. So here we're going to pick from a list of different space use types. And in this scenario we're going to look at a mixed-use hotel and restaurant. So we'll assign those use types by their space percentage. And then below we can see some of those impacts. We know the building square footage, floor area ratio, parking spaces, building coverage on the lot, and then peak traffic, parked cars, jobs, and daily water use for this scenario building. And so you probably ask, well, where are you getting that data? Well, the tool is very flexible and it allows users to define these different uses. We start with ITE-based impacts, but users can come in and add their own type of use, space use. So here let's put in a scenario, transit-oriented development restaurant, where we'll have, we expect fewer trips and fewer parked cars. Each column here represents an impact that we can analyze, and these columns are fully configurable as well. So depending on your own analysis needs, you could add that column in and the expected impacts based on a square footage. So we'll go back here and look at our massing again, and this time we're going to assign, we're going to remove that original restaurant and add our TOD restaurant, and we can see that the parking and traffic impacts have been reduced. And we'll save that data to the layer. And so while we understand the impacts for this initial building, what we want to understand is, well, what's the impact of this one scenario with the surrounding area, with the existing baseline impacts that we've calculated into the data model. So every building has its own impact. And here the companion tool on the impact reports allows us to see the existing and proposed impacts from these selected buildings. But for this scenario, we're actually looking at a corridor, and we see it here as a buffered area. And you see we have a whole set of infill buildings that we've assigned different use types based on our expected development scenario. We'll use the ArcPro's geoprocessing tool to quickly select those, and then the Impact 3D reporting tool again will allow us to see what those impacts are, both existing and proposed. We can also then look and scale out across a larger geography. While we may have a small planning area, we may want to look regionally and see what impacts are on the baseline as well as proposed. So here we're just making a quick selection on the map, but that selection can be driven by traditional spatial location, whether it be a watershed or a jurisdictional district. And the graphs and impact values are all, again, configured and can be shown based on your planning needs. So of course, plans are great, but we really want to find and see them implemented. So ArcPro allows us to import third-party data models. So in this pretend scenario here, we have a developer's 4-story mixed-use building on that same site with the basic site plan. And here we can bring it into the base map and understand visually how it looks. And we can also, of course, test how it fits within that zoning envelope. Maybe they'll need a small variance for that roof component, but it interacts and plays with all the existing data in the base map. And of course, once this building is built, the model becomes part of the base map itself, and it can be attributed with its own impacts and its own data to help support continued growth and continued use of the tools as plans develop. So we've been working with 3D GIS for a long time, and hopefully give you a sense of how we've evolved here, but we really are now seeing the 3D base map as a powerful and valuable tool for planners. One of the keys is this is really a living dynamic plan. You know, unlike those paper documents or those compiled visualizations, the 3D base map grows and can be modified and evolve as plans are implemented. These data can be managed with ArcGIS skill sets, and we know many planning offices have that expertise. And as you saw with the data model, we can leverage and integrate much of the existing data that's already available and already being used in your common planning practices. And then as Boulder showed in their great examples, all of this data can be easily shared out with some great information products. The second great thing we see here is ArcGIS Pro really showing itself to be a great tool and a single point of access to get at this data and to get at the functionality. It supports visualization of the built environment. We can create very flexible and dynamic data-driven 3D models, and we can support all kinds of analysis from the built-in geoprocessing tools to add-ins like Impact 3D. So we're really excited to see this capability grow, and it's great to see so many planning offices getting into 3D GIS. We think it's the wave of the future here.